Chapter 16, Problem 5. Predict the substance with the highest melting point. So we want to know what are our melting point factors. As the forces get stronger, the melting point will increase. Now, another thing that can affect the melting point is pressure. But I'm just going to write pressure affects it, because we're going to see that it's not always direct. So sometimes if you increase the pressure, it makes the melting point up. Sometimes when you decrease the pressure, it makes the melting point go up. So we're going to see this later in the chapter. So for now, we're going to focus on the forces. Part A, MgO or water. So MgO, this is an ionic compound, and water is a polar molecule. Ionic compounds have ionic forces. Polar molecules, they have automatically LDF, dipole-dipole, but water also has hydrogen on oxygen, so it has hydrogen bonding. So it seems like water should be stronger because I have a list of 3 forces there. But ionic forces are ridiculously stronger than LDF, dipole-dipole, or hydrogen bonding. So we can feel very confident that an ionic compound will have a higher melting point than a molecular. Now for part B, we have 2 ionic compounds. So what do we do then? So ionic compounds are held together with ionic bonds. And ionic bonds are Coulombic forces. So according to Coulomb's law, there's 2 factors that can affect Coulombic forces. One is the magnitude of the charge. So you want to have a high magnitude of charge. And you want the ions to get as close to each other as possible. But the easiest way to know that they're closest to each other as possible is if you have small ions. So you want to have large charge and small ions. And I would suggest you know it in that order. So think of this as the first and foremost, and then only if that is the same, consider the size. So going back to our substances, in MgO, we're looking at a +2 and -2. In KCl, we're looking at a +1 and a -1. So a magnitude of 2 is greater than 1. So we definitely would predict this to be a stronger ionic bond. Stronger ionic bond is going to make it have a higher melting point. Part C, calcium iodide or magnesium iodide. So once again, we have 2 ionic compounds. So first, we'll look at the magnitude of charge. In calcium iodide, we have +2, iodide -1. Magnesium, +2, iodide -1. So when you run into a situation where you have identical magnitude of charge, then you want to consider the size of the ions. So iodide is identical, but if we look on the periodic table, magnesium ion is smaller than calcium ion. So smaller ions allow for shorter bonds. Shorter bonds make it a stronger bond. So stronger forces are going to have a higher melting point.